Hey everyone, in this video, I would like to talk about Brahmagupta's formula for competition math. So here I give you the picture. I get a cyclic quadrilateral, and imagine that's a circle. We got A, B, and C, and D in this following form. So Brahmagupta formula can only be used when we're given with cyclic quadrilateral. And I would like to call this as A, I would like to call this as B, and here's C, and here's D. Okay, so check this out. We know by cyclic quadrilaterals property that the opposite angles are supplementary angles. I would like to call this as theta, and here's my theta, 180 minus theta. Okay. All right, so 180 minus theta, and here's what we're gonna write it down. By drawing one auxiliary diagonal of this figure, we can actually get the area A. That refers to 1/2 times A times B times sine theta, A times B times sine theta. And at the same time, I can add it by 1/2 CD times sine 180 minus theta. 1/2 times CD sine 180 minus theta. Okay, so what do you know about sine theta and sine 180 minus theta? If those two angles are supplementary, then we know that the sine values are congruent to one another. They're actually the same thing. So instead, without loss of generality, I'm just going to assume that sine 180 minus theta is just sine theta. So we have 1/2 times AB plus CD times sine theta. Okay. So instead of writing sine 180 minus theta, I would like to just write it as sine theta so that I can group it as, like using distributive property. And I would like to multiply 2 to both sides. So if I multiply 2 to the both sides, we get 2A equals AB plus CD sine theta. All right, so check this out. I would like to square this. Why? Because I want to somehow combine this using law of cosines. And of course, this was law of sines, but I would like to combine it with one of those sine squared into cosine squared. So if I take the square, that becomes 4A squared. And it is obvious that AB plus CD is going to be squared, and I can square sine squared. I can square the sine theta, but I can also switch it into 1 minus cosine squared. So I'm going to make it into 1 minus cosine squared for that, and part 1's done. Okay, I need to find out what cosine squared is, but I know how to write cosine theta. Why? Because I know for sure that this diagonal can be written as some kind of, I would say, K for sure. And the next part that we would like to write is, here's the next part. Shall I draw the vertical line? All right, so K squared equals A squared plus B squared minus 2AB cosine theta. And at the same time, I can rewrite it as C squared plus D squared, which is going to be C squared plus D squared minus 2CD cosine 180 minus theta, but cosine 180 minus theta is going to be negative cosine theta. So I'm just going to change the sign, and I would like to call it as cosine theta. All right, so check this out. These are the same expressions. Now we know that these are the same expressions. If I rearrange those two right sides of this equation, I can actually get something like A squared plus B squared minus C squared minus D squared, which is going to be 2 times AB plus CD times cosine theta. Wow, it kind of resembles of what we get. And I would like to take a square because I got AB plus CD squared and I got cosine squared in it. So if I rearrange all of these by multiplying or distributing AB plus CD squared onto the, to the second parentheses, I get AB plus CD squared minus AB plus CD squared times cosine squared. So probably it's going to be best if I just rearrange all of these by squaring both sides. So if I square the both sides, I get A squared and B squared minus C squared minus D squared squared. And obviously that turns out to be, let's erase this, that becomes 4 times AB plus CD squared, and we get cosine squared. Okay, so we're almost done, right? I really want to use 4 times AB plus CD squared and cosine squared in it. So how do I use it? I got to multiply 4 to the left side and the right side. So if I multiply 4 to the left side and the right side, I get 16a squared, and that becomes 4 times ab plus cd squared minus 4 times ab plus cd squared times cosine squared. All right, let's just try to push this all the way up here. All right, so we're almost done though. Okay, so that becomes 4 times ab plus cd squared. So I would say this will be 2 times ab plus cd, closing the parentheses and another parentheses, and that's going to be a square. And I know for sure from our example that 4 times ab plus cd squared cosine squared is just going to be a squared and b squared minus c squared and d squared square. All right, so I'm just going to rewrite it as a squared and b squared minus c squared and d squared square. So we have all those square ideas that are popping out, and I need to find what a is. Well, forget about that a. I know that this is just going to be difference of squares. So if I have the difference of squares, it's going to be better if I just write it as the product of the difference and the sum. This is going to take a while, but let's just do it one at a time. 2 times ab plus 2 times cd minus a squared minus b squared plus c squared plus d squared. Okay. So I got the difference first, and I'm going to find out the sum. Now, that becomes 2 times AB. All right, so let's use this pen. 2 times CD. I usually use my hands because, use my finger because it's better if I write it with fingers. Not that, I don't like pen, but here's what's up. So we have a plus A squared and B squared minus C squared minus D squared. Okay. So let's just try to move it up and let's see what happens. All right, so if you underline 2cd and c squared and d squared, just like this idea, well, that becomes c plus d squared. And I can see that 2ab minus a squared and minus b squared, if I imagine that has a negative 2, it seems like I can switch all of these expressions into c plus d squared minus a minus b squared. And you can check it by expanding it. All right, so we also have the similar expressions. I get a plus b squared, but at the same time, I'm just going to subtract it out by c minus d squared, and we have the given form, which is still 16a squared, which is not what I want. But hey, that's fine. So let's just try to rearrange this by, again, switching all of these difference of squares into the difference times the summation, or, the usual difference, like the difference and the summation part. And we have c plus d. We get c plus d minus a plus b. Ooh, so that kind of resembles the Heron's formula. And we can write it as c plus d plus a minus b. And you can check that a plus b minus c plus d and a plus b plus c minus d. And everything out here still 16a squared. If I divide it out by 16, I can distribute all those 2's into one of these parentheses, each of these parentheses, and still get 16 out, right? Still get 16 in the bottom part. Now you can check that c plus d minus a plus b over 2 is going to be s minus a, and that's going to be s minus b, and that's going to be s minus c, and s minus d. And what did I forget? I forgot about what s is. Well, starting to think about what s is, you got to think what we've learned in Heron's formula. S reminds you of semi-perimeter, and exactly the same word goes on, exactly same words being used in this example. All right, so A supposed to be square root of s minus a and s minus b and s minus c and s minus d. Of course, we gotta close it out here. Where shall I make it into the comma sign? Well, where s stands out for a plus b plus c plus d divided out by 2. And this is how we deduce the Brahmagupta's formula for cyclic quadrilateral. And of course, this is not commonly used formula. I mean, cyclic quadrilateral, and this is already a heavyweight material, right? However, this kind of gives you some kind of resembling picture, or the similar figures or similar ideas being used in Heron's formula as well. If you just set a as 0, then you can always find a certain triangle whose side lengths are B, C, and D, well, like proper like adjustment. But if you get all of these triangles with side lengths of B, C, and D where A is supposed to be 0, then you get Heron's formula. The special case of Brahmagupta will be the Heron's formula.